Okay, so let us solve this problem. So this math problem is from an SAT reviewer, and this is somehow related to the basic geometry. So let me teach you how to analyze and solve this. But before that, let me remind you to subscribe to my channel at the end of this video if you believe that you have learned something from this. So let's read this problem. First, a large cubical block of cheese measures 8 inches on each edge. If a small rectangular solid measuring 4 inches by 2 inches by 2 inches is cut out and thrown away, the volume of the remaining block of cheese is what fraction of its original volume? So let us illustrate this first. So yeah, this is a cheese, so we'll just use something a color close to a cheese. So all right. So it says that it's a cube, so it means that every edge is having the same length. Okay, so it says that it's 8 inches on each side. So it's 8 inches here, here. What else? Here, 8 inches. So I'll just transfer this one on the other side. So this 8 inches in height, length, and width. Now, if a small rectangular solid measuring 4 inches by 2 by 2 is cut out and thrown away, so let's illustrate that first. So I'll just use something or another color like red. I'm gonna remove this. It says 4 inches, so probably it means half of the 8, and then it's only 2 inches. So this part is being thrown away, unfortunately. So this is how much is this? So this is 4 inches by 2 inches by 2 inches that was being removed. So that is gone already. So what is it's not just simply asking how much is left, but what fraction is left from the original volume. So the question is, first question is, what is the volume of the original? So we'll just name it V sub O for the original volume. It's 8 times 8 times 8. 8 times 8 times 8 because it's a cube. So it's 8 times 8 is 64, and then 64 times 8. So what's 64 times 8, by the way? So 4 times 8 is 32, and 6 times 8 is 48. 48 plus 3 is 51. So that's 512 cubic inches. All right, so and then the one that is being thrown away is that is 2. So we'll name it thrown. So 2 4 times 2 times 2 is 4. Oh, sorry for this. So 4 times 2 times 2, which is 4 times 2 times 2 is this is 8. 8 times 2 is 16. So this is being removed. So what is left is, if I'm going to subtract this 2, so it's going to be how much is this? 2. So borrow from this. Okay, sorry for this. We're gonna write it in the other side. I mean at the bottom. So borrow from here. 0, 12 minus 6 is 6, and then borrow from here. 10 minus 1 is 9, then 4. So the volume that is left, so we'll name it LVL, since it's what's left or remaining, is 496 cubic inches. So no dimension given because we had just computed it. And the problem is, what is the um what fraction is the one left from the original? So if you say what fraction it is, it will be like this: volume of the what's left over volume of the original, which is 512 divided by 496, and then you are going to reduce it. But there will be an easier way to do it, but I'm gonna show that later. So to solve this, this is a longer way of solving. So then we're gonna reduce it, divide by 2. Obviously, it's divisible by 2, so it's going to be um half of 500 is 250, and then half of 12 is 6, so 256. And then 496, so half of 400 is 200, and half of 96 is 48. So you just keep on dividing until we get the least, I mean the simplest form. So half of 256 is 128. So I will not show anymore the manual computation of dividing. So, but that's the idea. You keep on dividing until it can't be reduced, meaning it can't be divided by a common divisor. So divide by 2. So as I said, it's a longer way to solve this, but I'm going to show you a shorter one later. So half of 128 is 64. Half of 124 is 62. And then they are still divisible by 2. So 64 divided by 2 is 32. Um, oh, I'm sorry. I have interchanged the values of this original and the one left. Let me rewrite that one. So it's 496 divided by 512. So we divided by 2. So we have here 256, and the top is 248, and then we divide it by 2. So we have a value here which is 124, and the bottom is 128, and then we divide it by 2 again. So we have 62, and the bottom is 64, and then we divide it by 2 again. So we have 31 and 32. So which is the answer actually? Which is D. So that's the ratio or the fraction of the original, I mean the one left from the original volume. And that's the longer one. So let me show you the shorter way of doing it. So what we're going to do is to just use the the volume of the one thrown, and take the fraction of that. And you might ask, why am I doing that if we are after is the one which is about the remaining, not the one thrown away? But you're gonna understand that later. So volume of the one thrown over volume of the one of the original. So I'm choosing that since it has a dimension, and it's easier for us to simplify this. So we don't need to compute it, so that it's easier for us to reduce. So we can cancel this. This is 4 and 8 because they are both divisible by 4. So this is 1 and 2. These two are divisible by 2, so 1 and 4, same as this. So the ratio between the one thrown away, and I mean, if I say ratio, it means fraction. So the fraction of the one thrown away and the original is 1 out of 2 times 4 is 8. 8 times 4 is 32. So 1 out of 32. So now what is the fraction of the remaining. So since the one thrown away is 1 out of 32, so the one that is remaining, so of course the original is the entire whole 32 out of 32. We remove the 1 out of 32, which is the one thrown away. So 32 minus 1 is 31. And then the bottom, we just copy it. Because that's how we subtract fraction. We just simply subtract the numerator. The denominator, we just simply copy it. So that's how you get the answer. And that is shorter and simpler to do. So again, the same answer. That's D, 31 out of 32.